Hello and welcome to another Energis AINet tutorial. Today we're going to be looking at another use case sample for the AINet platform, specifically detecting COVID-19 infection with routine blood exams. This paper was written in April 2020 and it'll be the basis of our analysis today. What this paper covers is detecting COVID-19 through routine blood exams and then analyzing it with machine learning. And throughout the paper, they go through a couple different methods of analysis, including breaking down trees, as well as KNN LR model, as we can see here. And they also list the accuracies of what they were able to get of about 85%, I believe. Included in the study is a COVID study Excel spreadsheet that takes a whole bunch of different indicators from blood samples, as well as the age and the gender of the patient, and whether or not they tested positive or negative for COVID. As you can see here, there's a lot of fields here that remain empty, so we'll have to fill those in with a placeholder value off the bat. So I'm just going to select all of these. I'm going to hit Control H. I'm going to find any empty cells, and I'm going to replace them with 9,999. Replace all just to fill cells and give an identifiable number for the machine learning model to fill in. As well, we have our gender here listed as male or female. So similar to the previous one, if the previous cell is equal to M, so I'll put in if A2 is equal to M. I'm going to make it 1, or if it's female, it'll be 0. And I'll expand that all the way down. Here you can see where there's female, it goes 0. And I'll move this header over and delete the first column. Actually, before I do that, I will copy it and paste it as values. Again, deleting the first column just to get rid of the non-numerical value. And here, our last column here is our swab, whether or not the patient tested positive for COVID or not. And we're going to move that over to another spreadsheet. So I'll go File, New, Blank Workbook, and I'll take this and I'll cut it out and drop it in the first column in the spreadsheet and save that as our COVID outputs, saved as .csv format. And with that, our data is already prepped and ready to go. We can directly drop this into our AINet platform. So opening up AINet, as soon as it's done loading, you can see I've already set up our model here. For reference, the model that I'm using here is the advanced very small numerical model with 20 input nodes, maximum 20 iterations and 50 hidden nodes. So this will hopefully give us the intelligence of our AI model required to detect COVID accurately, while still not overfitting to the relatively limited data set we have, as we only have about 280 patient records here. So loading up our data off the bat, because it's either a 1 or a 0, whether or not the patient has COVID, we're going to switch this over to a linear function because we aren't looking for a percentage on or off. We're just looking for either a 0 or a 1. We have one data input header on our inputs, one data input header on our outputs, and we're going to select our data files here as our COVID raw data.csv and our COVID outputs.csv. With that, we can submit our model to the server. It'll upload everything, and we can revisit it once it's completed. So now that our model is finished training, we can see that our AINet page is switched over to the active model menu, where we can submit our input data and receive our output data for items that it has never seen before. We can also flip over to the model metrics. We can see exactly what model was created for this, what it came up as optimal. And we can see that our model accuracy on average was plus or minus 0.37. So that'd be, if it's a 0, it'd be plus or minus 0.37 on 0, or if it's a 1, it's plus or minus 0.37 on 1. We can also see in the model history tab that from the time we submitted our training data, which was about 4:14 local time, to when our model was finished training, which was 4:23, is about 9 minutes to complete the training. So submitting our data, we can put in I'll just put in the raw data again to see, get some more specific metrics on how accurate our model is. So I'm going to submit that to the server and receive my data back. Now that we've received back, we can open it up in an Excel file again. I'm going to take a few different metrics here. I'm going to say for a 50% confidence that the person has COVID, a 75% confidence, and a 95% confidence that the person has COVID. So we're going to take this, we're going to do a simple if statement. So if this is greater than this, that means that the person has COVID for either 50%, 75, or 95%, and I'm just going to expand this throughout all the rows. Now, if we have a 1 in the first column, we're 50% confident that the person has COVID. If we have a 1 in the second column, we're 75% confident that the person has COVID. And if they have a 1 in the third row, we're 95% confident that the person has COVID. So now to see how accurate we are compared to the original data, we're going to pull up our original input data. We're going to open that up. It was the wrong file there. The templates. And we'll copy this all to our output file. So here's our column of our original data, and we're going to see how much of that is correct in the next 3. So I'm just going to move over our 3 data points here. We're going to say if this is equal to our output, then we're going to give it a 1. Otherwise, we're going to give it a 0. And we're going to expand that all the way down. I see here I'm going to have to block in that 1 so we don't accidentally change our columns as we shift it over. And then we're going to expand this over for our other 2 columns. Now that we're here, we can take the sum of this column, and we can divide it by the total number of entries, which in this case will be equal to 279. And we can see how accurate we were at predicting COVID. So here we can see that we were, for our 50% confidence, we caught 77% of the cases. With our 75% confidence, we caught 65% of the cases. And with our 95% confidence, we caught 48% of the cases. So to increase this number, there's a couple things we could do. It could be down to our original input data that we had, say our assumption here with our 9,999. In the original study, they actually used the mice technique to fill in this information with data. We could also make alternate AIs to help fill in this data based on full data sets that we have. It could also be down to our initial setup with our iterations. So here with our 15 input nodes, our 50 hidden nodes, and our 20 iterations, we're only hitting a fraction of the possible architecture combinations that there could be. So we might actually be better off increasing our iterations to, say, 50, for example. So that's exactly what I'm going to do now. So I'm going to open up the AI net. I've already added in the additional COVID-19 model here with the linear loss function as before, same amount of input data headers and output data headers. And I'm going to put in the same raw data and the same output data and see if this comes up with a better option with more iterations. So I'm going to submit that. It's going to upload to the server. And I'll return once it is completed its training. So now that I've gone ahead and submitted that to the server back at the active model menu, I'll add in and resubmit this data again with the COVID raw data file here, and I'll output it to the same location again, and I'll submit that. When I've received back my file, I can go back into my folder and I can see that I have a new entry for output data. Over here in the model metrics, we can see that it actually picked up a different one. This time we have 3 first layer nodes with 2 second layer nodes, no third layer nodes, and we're giving a accuracy of plus or minus 0.34. So it doesn't seem too different from what we originally found. I'll just go ahead and drop it into this analysis file here. So keep in mind we originally had around 77 to, 77, 65, and 48. I'll just copy these and paste these as values so we can keep these as reference. And I'll go ahead and just copy and paste this into our first file, which will recalculate the rest of them. We can see that we now have 72, 72, and 36. So we gained accuracy on our 75% model. We lost a little bit of accuracy in our 95 and our 50% models. So to improve our models from here and to improve the accuracy that we're getting, we're basically restricted now to improving our actual data set, whether that's using the mice to fill in these blank entries that we had off the bat instead of 9,999, or having more entries here, more than 294 could also be another way to improve our accuracy. Please like and subscribe to keep receiving new model use cases and using our AINet platform. Thank you for watching, and good luck on your future AI projects.